Hello and welcome to the Science Oxford Centre livestream 2022. My name is Daniel and I will be your host here in the Science Oxford classroom today. Thank you so much for joining us. We have got lots of fantastic demonstrations to show you, but I could not do all of this by myself. So I would like to introduce Alicia, who will be here helping set up, clear away and run some of our experiments. And I'd like to also say welcome to Sarah and Sean, who are running all of our technical support, making sure that we can stream this live directly to you in your classrooms. And just a quick note about the live chat. So we've got the live chat available for you. We asked you a question at the start, and throughout the show, we will ask you various questions and give you a bit of time to discuss that in your classroom. And teachers, it would be great if you could pop some answers into the live chat there for us so that we can share them with the rest of the group and discuss them. Now, at the start of the show, we asked you, where do clouds come from? I wonder if anyone's got any ideas of where clouds might come from. Well, I can tell you that clouds are made of water. So all the water you see on the ground, maybe in puddles after it's rained, or in ponds or lakes or the ocean, some of that water on the surface sometimes gets enough energy that some of the water particles can leave the water and they go up into the air. They turn into water vapor, okay, in a process called evaporation. So water can evaporate up into the air, and then there's water vapor invisible around us in the air all the time. And as the air gets warmer, because the sun is shining on the ground, or because we've got the heating on in the buildings and that's heating up the air around us as well, that air starts to rise and it carries the water vapor with us. And we can see heat rising in all sorts of situations. You might have seen steam coming out of a kettle or smoke from a fire. All those hot things are rising up. And I'm going to show you a demonstration now to show you that heat does rise up and can lift things with it as well. So over here, I've got a few different pieces here. I've got a little tea bag. I do love a cup of tea, but for this one, I'm not going to be drinking it because I'm going to be using it for this experiment. So I'm going to get my tea bag out of this little packet. And unfortunately, I don't even need the tea. So what I'm going to do is I'm going to cut the top of the tea bag off, a nice straight line across the top there. And I'm going to tip all this tea away because all I need is this thin, papery material, the tea bag that the tea bag is made of. And if I clear out all the tea from inside, you can see that I've got like a little papery tube with a column of air running through the middle. Okay, so there's just air inside that. I'm going to stand it up on its end here. And I'm going to try to heat that air up with enough heat that it will lift the tea bag off the table as well. And the way I'm going to do that is by setting the tea bag on fire. So I'm going to light the top of the tea bag here, and let's just watch as the tea bag starts to burn away. That air is getting hotter and hotter because of the fire, and it's trying to lift it up, it's trying to push it up. And as the tea bag gets lighter, whoa, there we go. So as the tea bag got light enough, the power of the warm air rising up could carry the tea bag with it. Now, just in case you missed it, because it goes quite fast, I'm going to try another one here. So, get my second tea bag. I'm going to cut a nice straight line across the top. I'm going to tip all the tea away carefully into my little container here. And I've got my column of air inside the paper bag. And a bit like a rocket, we're going to give it some fire there to heat it up. And if it gets enough heat, it should hopefully rise up off the mat. And I can see that floating around in the air. In fact, I can grab it out of the air. Oh, it's just fell to ash. There we go. So there we can see that heat rises and warm air rises, and it carries with it the water vapor that's in it. And that water vapor gets high enough into the atmosphere. But as it gets higher and higher, the air pressure starts to drop, and pressure and temperature are related. So that means that the temperature starts to drop as well, which means that water vapor that was nice and warm starts to get colder. And as it gets colder, it turns back into little tiny water droplets through a process called condensation. Now, you've probably seen condensation if you've ever breathed onto a cold window or a mirror. You might see a little bit of fog on the glass there. That is the water vapor in your breath condensing on the cold glass. So as that water vapor gets colder, it condenses back into tiny little droplets, droplets which are about 100 times smaller than a millimeter. So you could barely see them. But when we get billions of them together, they make enormous clouds up in the sky, and that's what we see as clouds. So that's where clouds come from. Water vapor, which has risen up through evaporation and then condensed when it gets colder. And I'm going to try and show you now a cloud in this very room. I'm going to try and make a cloud in a bottle. So in this bottle here, I've got a little bit of water down at the bottom. And I'm going to give it a spin around and try and get as much of that water to evaporate as possible. Give it lots of energy by shaking it around. Okay, so now the water in there is actually in a vapor form. So it's the invisible gas inside the bottle. And what I'm going to do is I'm going to increase the pressure in this bottle with the help of Alicia. So if you could come over here, Alicia, for me. I'm going to open this up. We're going to use this bike pump to add a bit more pressure into this bottle. So watch inside the bottle here. That water vapor inside is getting under higher and higher pressure, which means it's getting warmer and warmer. And in a moment, I'm going to release some of that pressure. Thank you very much. And as the pressure drops, just like it does to the water in the sky, the temperature is going to drop. It will condense back into a cloud. And you can probably even see a little bit of the cloud coming out the top of the bottle there. So that is just the water droplets having condensed back in. I'm going to put this back on. Alicia, can you give us a few more pumps on there? So watch the cloud. It's cloudy inside. And then as the pressure and the temperature increase, it evaporates back into a gas again. So just like if you've seen mist in the morning seem to disappear as the sun comes out, the same thing is happening. That water vapor is rising up. And then when the pressure drops and the temperature drops, it condenses back into that liquid again. And you can see I've got inside here a cloud in a bottle. Fantastic stuff. Now, what happens to clouds afterwards? When they've been formed, they're not just there all the time forever. Those little water droplets start bumping into other little water droplets, and those water droplets get bigger, and eventually they get so big that the warm air can't keep them up, so gravity pulls them back down out of the cloud as rain. And sometimes you might have noticed, sometimes after it rains, we see something very colorful in the sky. I wonder what it is that we see in the sky. You might know it as a rainbow. So I want you now to spend a couple of minutes talking with the people in your class about what you know about rainbows. What are the colors of a rainbow and what makes a rainbow? And welcome back. Thank you very much. So we asked you, what do you know about rainbows? What colors make up a rainbow? How are rainbows made? Well, as you can probably see behind me, the 7 colors of the rainbow that we can easily detect are red, orange, yellow, green, blue, indigo, and violet. Okay. And the reason that we can see those are because, oh, hang on, I think I've got some comments coming through now. So North Marston think that it has something to do with rain being hot. And we also said it needs to be sunny. Fantastic. Thank you very much for sharing that. So the rain is still up in the air, so it's still got a bit of warmth to it. And we definitely do need the sun as well. Now, the sunlight produces white light. Okay, so we see the sunlight as white light, and it sort of gives color to everything because white light is made up of all those colors combined. When the sunlight hits a raindrop or enough raindrops in the sky, it gets split up into all these different colors. And we've created the one here in the classroom by using a piece of scientific equipment called a prism. Okay, so a prism is a triangular shape like this. And when the light, look at a white light shining at it, it comes in from one side and it sort of gets bent as it travels through. And when it comes out, all of those different colors have separated out. And you can see the rainbow effect behind me here. And it's just the same with water droplets left in the sky after it's been raining on a very sunny day. If they hit it at just the right angle and you're stood in just the right place, you will see a beautiful rainbow in the sky above you. Now, white light is made up of all these different colors, as I said, but we can also play around with different colors to try to recreate white light. So over here, I've got some torches that I've made, and I've got some little filters over the top of them. So you can see here, I've got a red filter over my torch, which when I turn it on, gives me a red light. And I've got a blue torch with a blue filter, which should give me a blue light. There we go. And I've also got a green torch with a green filter to give me a lovely green light. Now, when you think about primary colors, when you're thinking about painting maybe, you probably think of red, yellow, and blue. And you'd be absolutely right. Those are your primary colors for painting. But when we're using light, our primary colors are red, green, and blue. And just like when you're painting, if you mix 2 different colors together, you get a secondary color. So if I were to mix my red and green, what color do you think I would get? Let's have a little look. So when red and green light combine together, it gives us yellow light. I wonder who guessed that correctly. What happens, do you think, if I mix my red and my blue light together? What color do you think I'd get from mixing red and blue? Here we go. I get the color we call magenta. It's a purplish kind of color. It's beautiful. And finally, what do you think I'd get if I mixed green and blue? If I mix my green and blue lights together, we get cyan, which is a greeny bluey color, but we call it cyan. Now, that's what happens with mixing 2 colors together. But if I mix red, green, and blue all onto the same place, you can see that it recreates white light here in the middle. Okay, so I've got my red, green, and blue all coming back together to combine to make white light. Now, it's not just colored lights we can play around with, but we can also play around with colored shadows. So if I have my blue light or my green light shining on the wall over there, and I put something in the way, we can see that I get a black shadow with a green background, because all of that green light is hitting this and it can't reach the wall at the back. If I add in my red light, you can see that I get a red shadow and a green shadow on the yellow background, because where the green and the red light are mixing together, we get that yellow color. Where the red light can't shine here, it's left this shadow, but the green light can shine there, so it's illuminating that shadow, giving us a green shadow. And over here, the green light can't shine, but the red light can, leaving us with a red shadow. And if I swap them around again, so if I take out the green torch and I add my blue, you can see that we get a blue shadow and a red shadow on the magenta background. And I can swap the green one in for the red, and we get a green shadow and a blue shadow on the cyan background. Isn't that amazing? Now, just like before, I mixed all of my colors together. Well, here I've stuck together 3 torches of those 3 colors. So it should give me a lovely white colored light combined. But when I place it here, if I bring this shadow maker forward, we can see I get all of those different colored shadows. I've got the blue, the red, and the green. I've got the magenta, the yellow, and the cyan. And they're all on a white background. And here in the very middle, none of the lights are reaching that section. So that's left a black shadow. Different colors are combining together or shining alone. They've made different colored shadows. And you can play around with this kind of thing yourself. You can buy expensive colored torches if you like, or you can do what I did and just take some regular torches and put some sweet wrappers or something over the top. In fact, Alicia, have you got any kind of sweets we might be able to use? Fantastic. So at this time of year, I usually have one of these kind of sweet... What did you do?
Nothing.
What happened then?
I don't know.
You seemed to put it on the ramp and it rolled up the slope. How on earth do you think that happened? Do you think you could have a quick discussion in your class? Why do you think the tin rolled up the slope? We'll come. Hello and welcome back. I hope you've had plenty of chance to discuss the ideas of why the tin seems to roll up the slope. Let's just have a look at that one more time. So I place it over there and I just let go and it rolls up the ramp to my hand. How peculiar. I wonder what ideas you've come up with. Let's have a look. So I can see that Jude Zabel has said magnets. That's a fantastic idea. So I could be using some kind of magnetic attraction or repulsion to force it to roll up the slope. It could be done like that. Fantastic. We think there is air in the tin that's doing something to make it move, says Alexandra Mullins. You're absolutely right. There could be some kind of fan or motor inside moving things around, and that makes it roll as well. Very good idea. And then Amy Aldridge from North Marston says maybe there is a magnet, or maybe there might be a weight all in one part of the tin. So if it was overweighted, it might cause it to unbalance and roll, and that might make it move up as well. Those are all fantastic ideas. I'm sure it could be done in any number of those ways. I'm going to challenge you to try and have a go at making one of these yourself and seeing if you can do it. But today, I'm not actually going to tell you what I did to make it roll up the slope. I'm going to leave that a mystery for you. But what I will do is I will show you how I can make this Diet Coke can roll up the slope with a few different ideas maybe using some different types of weather phenomena. So the first one I could do is I could force it up the ramp with the power of wind. So I'm going to give it a quick blow like this. Whoa, quite a powerful wind, can blow it straight up there. So I could have blown it up there as well. I could also use a different kind of weather-based phenomena. So I'm going to rub this balloon onto my shirt. You might have done this before yourself. And when you rub two materials together like this, you can sometimes create a static charge. So let's see if this balloon has got the power to move the Diet Coke can without touching it. I'm going to try that again. Oh no! It did start to move. We'll do that one more time. Fantastic. So I generated a static charge on the balloon by rubbing it together on my shirt, and that meant that it was attracting the Diet Coke can without touching it. It was sort of pulling it towards it. Okay, and I can even make the balloon attract to other things as well. So inside that balloon now, because I rubbed it with a different material, I generated a strong static charge, which has now made it attract to the wall, and the attraction is strong enough that it can support its own weight. There's no blue tack or sellotape up there. I can move it, I can take it down here, and stick it up there as well. Okay? So it's holding itself up with its own static charge. And you can generate static charges when you rub two different materials together, and then suddenly one of them can attract or repel other objects. Okay? And that's how I made that Diet Coke can move up the ramp. It was attracting it up the ramp. Now we've seen attraction. Let's take a look at repulsion. I'm going to see if I can now generate a strong static charge to repel these objects. So this machine in front of me is called a Van de Graaff generator, and it's a very powerful piece of equipment which will generate a very powerful static charge. Okay? These machines can be dangerous if used incorrectly, so I've been trained in how to use this properly. Okay? Because inside the machine there is a rubber belt which will be moving around very fast, rubbing against the inside of this metal dome, generating that same kind of static charge from when I rubbed the balloon on my shirt. Okay? And it's going to build up inside here. And we'll see if it will repel the things I've put on top. I'm just going to hold on to this for safety. Fantastic. So as you can see there, that static charge was doing the opposite of attracting, pulling things towards it. This one was repelling all the things, pushing them away. So it made them all move off quickly into the air. Now, when a static charge has built up on an object like this, if it keeps building like the Van de Graaff generator does, it will try to discharge. And a discharge from a static charge like that is the same kind of thing you might have experienced if you've ever had a static shock. So if your materials on your clothes might have rubbed together and you've gone to open a door or touch another person, sometimes you get a static shock because you've built up a charge and it jumps through the air to another object to discharge. Okay? When it jumps through the air, it's like a little bolt of electricity traveling through the air. We're going to use this machine now to see if we can see that. So if you see between the big dome and the silver ball, can you see those flashes of sparking electricity? And you might be able to hear the sound as well of that crackling electricity. There we go. Just going to get the lights back up. Now, does that remind you of any other kind of weather? Yes, electricity jumping through the air is how lightning works. So lightning is generated in storm clouds when those water droplets we talked about earlier are getting pushed up by the warm air to the top, but then they freeze very quickly and turn into hail, and then they fall back down, and then the water droplets are being pushed up, and the hail is coming down, and they're rubbing together against each other, generating that same kind of charge we've seen here because they're rubbing together. And when the cloud has built up enough of a charge, it needs to discharge. And sometimes it discharges to the ground with a striking lightning bolt like we saw between those two things. Sometimes it arcs over to other clouds as well. And along with lightning, we also hear that enormous rumbling sound of thunder. Now with this, it was only a small bolt of lightning, so it was a small crackle of thunder. But it's much larger in a storm cloud, so the thunder is much louder as well. Now, we have talked today about clouds. We've looked at rainbows, and we've looked at lightning and thunder as well. And there are so many other types of weather and meteorological phenomena that you might be interested in that are really exciting and have a really interesting scientific explanation. So if you've got any questions about weather generally that you'd like to put into the live chat, we'll leave it open at the end for you to type in your questions and we'll try and get back to you, or you can email them to us and we'll try to respond to you that way as well. Before we end the show, I just want to say thank you very much to Alicia and Sean and Sarah for all their help with putting this together. I could not have done it without them. I'd like to say thank you to you for taking part and joining in today. And I want to leave you with a final question as well before we go, because I'm sure if you've looked outside, you've seen recently, there's been a bit of snow around. So I want to know if you can tell me, how is snow made? Okay, we're going to leave that up on the screen. You can put your answers in the live chat if you like. We can have a discussion in your class. And I'm just going to read through some of the schools that have joined us today. So thank you very much to Cutslow, North Hinksey, Cropredy, Kings Langley, North Marston, Barton Park, Horsepath, All Saints, Hanborough Manor, Bampton, Juniper Hill, Queensway, North Kidlington, Grove, St Nicholas, Pangbourne, St Finian's, John Henry Newman, and St Ebbs. Thank you so much to those schools, and thank you to you if I didn't call your name out there. We really appreciate you joining us, and we'll hopefully see you again on the next one.